Okay, welcome to our class today, guys. June 14th, 2022. We took in the first part in the previous uploaded video on our YouTube channel about the project and the final exam and the class schedule. And now we will continue with our curriculum. So I'll share my screen right now. So this is handout 3. We'll have like a little handout. Then we'll watch like 2 videos or 3 videos, which will introduce next class slides. Okay, because we'll not depend on videos on this topic. In the previous topics, we depend on videos. I will add some handout about those, like linear algebra. I add a slide about linear algebra, but about optimization and the probability, I will add also some slide to support the videos that we watch. But as of now, even if we watch a video, we'll have also a presentation and a slide explained in deep details about the address topic. So these just videos like a kind of like ice breaking to just put you on inside the mode. So our outline for the first part of our lecture today, introduction about types of machine learning. How does machine learning work? Different types of machine learning, applications of different types of machine learning. So I will start in the introduction. Machine learning, as we talked before, is one of the most common applications of artificial intelligence nowadays. A machine learns to execute tasks from data fed in it, which we call training data. And with experience, its performance in a given task will be improved. Machine learning includes 3 main types: supervised learning, unsupervised learning, and reinforced learning, or reinforcement learning, we call them. And there are some in between, like semi-supervised. We have some different subtypes. Machine learning is an essential branch of AI, and it finds its uses in multiple sectors, including, for example, in e-commerce sites, healthcare, in social media, in finance, in automotive, which mean like self-driven vehicle, smart vehicle, smart cities, smart homes nowadays, in communication, in networking, in like 4G, 5G, 6G. Now they start talking about it. Security, like cyber security, network security, communication security, and many more. You can find it like business intelligence, a lot of applications or fields that can apply intelligence techniques using machine learning. So how does machine learning work? In machine learning, you put in some training data, which trains the computer. It uses the data for creating a model. This model will be used to check any new input gets in that application or model. Then it uses them to make predictions. If prediction turns out to be wrong, the computer restarts the process again until it makes a right prediction, which means that here how it's our tries in order to improve the performance of the machine learning model under consideration. As you must have noticed, the system learns whenever it makes a prediction. It was just a simple example. Machine learning algorithms are quite complex and require many other steps. Different machine learning tools allow you to explore the depth of data science domains, experiment with them, and innovate fully functional AI machine learning solutions. Different tools are designed for different needs, so the choice of machine learning tools will largely depend on the project at the hand, on the nature of data set, what is the nature of the problem under consideration, the expected outcome. So sometimes your level of experience would be improved, would be complex, would be tricky a bit. And we'll talk about all of these in the coming chapter. Like sometimes you have imbalance problem. What is imbalance problem? How we will overcome it? We'll talk about that on the proper time during the course. So again, we have three different types or main types of machine learning. They are supervised learning, unsupervised learning, reinforcement learning, and there are some other subtypes in between. So supervised learning is when you provide the machine with a lot of training data to perform a specific task. For example, to teach a kid the color red, you'd show him a bunch of red things like an apple, a red ball, right? So if we want to train a kid about colors, then we should show the kid something he would love with the red color. Then we'll tell him all of those red. Next step, we'll teach him the yellow, then the blue. Then after, we will start mixing them and make sure that the kid differentiate between these colors. We are simulating this scenario for a human, how we learn a human, either kids or adult or whatever the learning. We try to simulate this using machine learning techniques. After showing the kind of bunch of red thing, then you show him red thing and ask him what color it is to find if the kid has learned or not. In supervised learning, you similarly teach the machine. It is the most accessible type of machine learning to implement, and it is also most common one. In the training data, this is about supervised learning we are talking. In the training data, you'd feed the machine with a lot of similar example, and the computer will predict the answer. You would then give feedback to the computer as to whether it made the right prediction or not. So here are simple examples. You give the machine with the following information. If we enter a string, 2,7 equal 9, 5,6 equal 11, 9,10 equal 19. Now, if we give the machine the following question, 9,1, what should be the answer? Guys, hello? Do you hear me, guys? Yes, 10. Yes, thank you, guys, for those who answered 10. So we're given two numbers with a comma equal certain number, then we have to train the machine to give the prediction. Guys, here we are talking supervised prediction. We didn't come to classification or regression. Is that clear? So we talk about supervised in general, at the surface level, at the abstract level. So it's doing a prediction. What types of a prediction? Then we'll come to classification and or regression or estimation. 8 and 9, what should be the answer? 17. Yes. 20 and 4 should be 24. Thank you, guys. So here we use those as a training data, then with new instance, and then we have to check if the computer or the machine learning model or the AI model predict the answer correctly. Yes, 24. Thank you, guys. Depending on the machine answer, you would give it more training data or give it more complex problem. So either if we find the number of mistakes is more, then we'll give fit and more training data till we find that the computer almost 100% accurately give the prediction. Supervised learning is a task specific. What do we mean by task specific? That we ask the model to do specific thing. And that's why it's quite common. Now we'll come to the next part, which is unsupervised learning. What do we mean by unsupervised learning? As the name suggests, unsupervised learning is the opposite of supervised learning. In this case, you don't provide the machine with any training data. We don't train the machine. The machine has to reach conclusion without any labeled data. It is a little challenging to implement than supervised learning. It is focused on clustering. So it will cluster some similar data in certain cluster, then you will find your data separated in different clusters. It is used for clustering data and for finding anomalies. Following the example we discussed above, suppose you don't know or show the kid different red color things in the beginning. Instead, you put a bunch of red color and the green color, then in front of him, ask him to separate them. This is the unsupervised. So we bring to the kid like a mixed red and the green balls or green color balls. Then we ask the kid, without asking him about what is this color, separate them in two clusters. This is the unsupervised learning. So suppose you have like the example, suppose you have different news article and you want them stored into different categories. You'd give the article to the machine and it will detect commonalities between them. It will then divide the articles into different categories according to the data. We call them different clusters. Now, when you give a new article to the machine, it will categorize it automatically. Just like other machine learning types, it is also quite popular as it is data-driven models, not task-specific. It is data-driven model. Okay, now let's talk about the third type. What do we mean by reinforcement learning? It's quite different from other types of machine learning, supervised and unsupervised. The relation between data and machine is quite different from other machine learning types as well. In reinforcement learning, the machine learns by its mistake. What do we mean by that? You will give the machine a specific environment in which it can perform a given set of actions. Now it will learn by trial and error. Is this a spam? If it is a spam and you know it is a spam and the machine classify it as normal, then you have to put some feedback. And we call them penalty and awards technique. So an example we discussed before, suppose you show the kid an apple and the banana, then ask him which one is red. If the child answers correctly, you'll give him a candy, which we mean reward. And if the kid gives a wrong answer, you don't give him the same. We call it penalty. In reinforcement learning, the machine learns similarly. Questions about the three different types of machine learning, or the three main types of machine learning? Questions, guys? No questions. Sounds good. So what are the examples of reinforcement learning? You give the machine a maze to solve. The machine will attempt to decipher the maze and make mistakes. Whenever it fails in solving the maze, it will try again. And with each error, the machine will learn what to avoid. By repeating this activity, the machine will keep learning more information about the maze. By using that information, it will solve the maze in some time as well. Although the reinforcement learning is quite challenging to implement, it finds application in many industries. However, it is difficult and it's not an easy technique, but it has some application. It has some application. One of the application, like if you are in like food spices manufacture, and you need the machine to differentiate whether this is a common, this is like a cinnamon, this is like mint, whatever. So this kind would be like some kind of machine learning. But for example, some other will say, oh, deep learning with CNN, deep learning models can use image classification to classify those. You are correct, but in some other reinforcement learning is needed. So what are the applications of different types of machine learning? Here are some real applications. Like supervised learning, we can use it for face recognition, spam filter, identify spam email by checking their content, recognizing faces and images like Facebook or Google Photos. Unsupervised learning, recommendation system, recommended product to buyers such as Amazon. data categorization, categorize data for better organization, clustering data, customer segmentation, classify customer into different categories according to different qualities. So here we need supervised learning, like classifying a student like good, excellent, fair, need help. If he is weak, we will use unsupervised learning to identify or to classify students. Reinforcement learning, like manufacturing industry, streamline the automated manufacturing process. Robotics need reinforcement learning, teach machine on how to avoid mistakes for robots, for example. Video games, better AI for video game characters and NPCs. So here with video games also reinforcement learning playing a vital role there. Questions? So this is a brief introduction. This is a brief introduction about the types that we are going to study in deep details by algorithms with pros and cons of each algorithm, how it's mathematically represented in some level of details. We might go with some algorithm in more deep details mathematically. Some of them will like a generic idea. Data pre-processing techniques, all of those are coming through the curriculum. So questions, guys? Okay, now we will see some quick videos for the other part of today. Just a second. Okay. So I'll share my screen now. Is the sound good? Yes, no? Okay, thank you. Thank you, guys. Let's continue. Here, as I mentioned, we will start with supervised learning. We have two things in supervised learning. Either we have a classification problem and regression problem. So we'll talk about those two types. Let's continue.
Hello everyone, welcome to W3 Grad's Quick Tech Solutions. Today's video is based on supervised learning in machine learning and its types, that are regression and classification. So, let us quickly see what supervised learning is in machine learning. Supervised learning is the machine learning task of learning a function that maps an input to an output based on example input and output pairs. It infers a function from labeled training data consisting of a set of training examples. In supervised learning, each example is a pair consisting of an input object, which is typically a vector, and a desired output value, which is also called the supervisory signal. A supervised learning algorithm analyzes the training data and produces an inferred function, which can be used for mapping new examples. Techniques of supervised machine learning algorithms include linear and logistic regression, multi-class classification, decision trees, and support vector machines. Supervised learning requires that the data used to train the algorithm is already labeled with correct answers. For example, a classification algorithm will learn to identify animals after being trained on a data set of images that are properly labeled with the species of the animal and some identifying characteristics. Regression and classification algorithms are supervised learning algorithms. Both the algorithms are used for prediction in machine learning and work with the labeled data sets. But the difference between both is how they are used for different machine learning problems. The main difference between regression and classification algorithms that regression algorithms are used to predict the continuous values such as price, salary, age, etc., and classification algorithms are used to predict or classify the discrete values such as male or female, true or false, spam or not spam, etc.
Okay, so do you know the difference between when we use regression and when we use classification? When we use regression, we have a continuous value. What do we mean by continuous value? Like we are estimating number. or a predicting number, like income, inflation, commission, as the author of this video mentioned. If we are using a classification problem like attack or not in network communication, in car, like in smart car, in vehicle, is it obstacle or not in the road, male or female, pass or fail, yes or no, these kind we call them classification, and we deal with discrete items, not continuous item. Continuous item are consisting of numbers and etc. Discrete items we are using with specific names or with a specific label to the output of the data set and the model. Let's continue.
Let us look at what classification algorithm is in a bit of detail. The classification algorithm is a supervised learning technique that is used to identify the category of new observations on the basis of training data. In classification, a program learns from the given data set or observations and then classifies new observation into a number of classes or groups, such as yes or number, 0 or 1, spam or not spam, cat or dog, etc. Classes can be called as targets, labels or categories. Unlike regression, the output variable of classification is a category, not a value, such as green or blue, fruit or animal, etc. Since the classification algorithm is a supervised learning technique, hence it takes labeled input data, which means it contains input with the corresponding output. In classification algorithm, a discrete output function y is mapped to input variable x and represented as y as a function of x, where y is the categorical output. The best example of a machine learning classification algorithm is email spam detector used by email services. The model is trained on the basis of millions of emails on different parameters, and whenever it receives a new email, it identifies whether the email is spam or not. If the email is spam, then it is moved to the spam folder. The main goal of the classification algorithm is to identify the category of a given data set, and these algorithms are mainly used to predict the output for the categorical data. Classification algorithms can be better understood with the help of this diagram as shown. In this diagram, there are two classes, class A and class B. These classes have features that are similar to each other and dissimilar to other classes. Now, the algorithm which implements the classification on a data set is known as a classifier. Now there are two types of classifiers, which are binary classifier and multi-class classifier. If the classification
what do we mean here by binary classifier or multi-class classifier? If I'm classifying, for example, network traffic as normal, or some author call it benign, or attack, or intrusion. So this is a binary classification. In the same example, I can identify also the attack type, like IDS, phishing, denial service attack. So this will call it multi-class classification. Let's continue.
Problem has only two possible outcomes, then it is called as binary classifier. For example, yes or no, male or female, spam or not spam, cat or dog, etc. If a classification problem has more than two outcomes, then it is called as multi-class classifier. For example, classifications of types of crops and classification of types of music. But when it comes types of classification algorithms in machine learning, it can divide it into two main categories and subcategories, which are linear model and nonlinear models. The examples of linear models are logistic regression and support vector machines. On the other hand, the examples of nonlinear models are k-nearest neighbors, kernel SVM, naive Bayes, decision tree classification, and random forest classification. So, this completes our discussion on classification algorithm. Now, let us move further and look into the regression algorithm in detail. Regression is a process of finding the correlations between dependent and independent variables. It helps in predicting the continuous variables such as prediction of market trends, prediction of house prices, etc. The figure shows the graph with independent variables on x-axis and dependent variables on y-axis. The graph contains data points and a line of regression. This line indicates the best fit line for predicting any output. The task of the regression algorithm is to find the mapping function to map the input variable x to the continuous output variable y. Let you take an example of regression. Suppose we want to do weather forecasting, so for this, we will use the regression algorithm. In weather prediction, the model is trained on the past data, and once the training is completed, it can easily predict the weather for future days. In machine learning, we have different types of regression algorithms. These are simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regression, and random forest regression. To conclude, let us do a comparative study of classification and regression based on different parameters. The table shows a comparison between classification and regression. The first point says that, in classification, the mapping function is used for mapping of values to predefined classes, whereas, in regression, the mapping function is used for mapping of values to continuous output. Classification involves prediction of discrete values, while regression involves prediction of continuous values. The nature of predicted data in case of classification algorithm is unordered. However, in case of regression, it is ordered. The method of calculation in classification is simply by measuring the accuracy, while regression involves calculation of root mean square error as the method of calculation. The examples of classification algorithm are decision tree, logistic regression, etc., whereas regression tree or random forest and linear regression, etc. So, this brings to the end of this video. Hope this video cleared out the concept of classification and regression in machine learning. So, keep learning, and I will see you in next video.
Okay, is the idea clear? What is the difference between a classification and regression? We'll have a handout next week. We'll discuss it again in more details. But as a concept, is it clear? Any questions? Okay. Now let's talk about linear regression. We'll start talking about regression before classification.
Hi, and welcome to the new lecture in the fun and
Is the sound clear? Okay, sounds good. Let's continue.
easy machine learning series. Today I'll be talking about linear regression. Linear regression attempts to model the relationship between two variables by fitting a linear equation to the observed data. One variable is considered to be an explanatory variable, while the other is considered to be a dependent variable. Please don't forget to subscribe and click the bell icon for more videos on machine learning. So the dependent variable, it's a variable whose values we want to explain or forecast. The independent or explanatory variable is a variable that explains the other variables, and the values are independent. Dependent variables can be denoted as y. So you can imagine a child always asking why is he dependent on his parents. And then you can imagine the x as your ex-boyfriend or girlfriend who is independent because they don't need you or depend on you. A good way of remembering it. Anyways, linear regression can be used in one of two ways: to establish if there's a relation between two variables, or see if there's a statistically significant relationship between the two variables. So for example, you want to see how an increase in sin tax has an effect on how many cigarette packs are consumed, how many sleep hours versus test scores, see what's the correlation between experience versus salaries, Pokemon versus urban density, and house floor area versus house price. The second application is to forecast new observations. We can use what we already know to forecast unobserved values. Here are some examples of the way that linear regression can be applied. So say the return on investment of fidget spinners over time, as well as stock price over time, or to predict the price of Bitcoin over time. So you can think of linear regression as the line of best fit. So the line of best fit can be represented by the linear equation y equals a plus bx, or y equals mx plus b, or y equals b subset 0 plus b subset 1 times x. You mostly learned this in school. So b is the intercept. If you increase this variable, the intercept moves up or down along the y-axis. And m is the slope or gradient. If you change this, then the line rotates along the intercept. So data is actually a series of x and y observations as shown on the scatter plot. They don't follow a straight line. However, they do follow a linear pattern, hence the term linear regression. Assuming that we already have the best fit line, we can calculate the error term epsilon. also known as the residual. And this is the term that we would like to minimize along all the points in the data series. So say we have our linear equation represented in statistical notation. The residual fits into our equation as shown: y equals b0 plus b1 times x plus epsilon. Okay, let's try doing this by hand in an example. Okay, so over here we have our dataset of Pokemon versus urban density. And this dataset you can get from my GitHub repository under range GT09 and machine learning FNE, which stands for fun and easy. Go to lab 1, linear regression, and then you will have the homework package that you can work on, and then as well as the solution. Over here on this site, you'll be able to find the same dataset as well as the equations to finding the coefficients of A and B. And then to find the correlation coefficient squared, you can find that equation right over here. And you can just follow the address. Okay, so we have Pokemon, which is on our x-axis. Our y-axis is urban density. And then we can create a plot, a scatter plot of that. And then we can just format it to make it look a little bit nice. You can add in some data labels. And then we're gonna be calling this urban density on the y-axis. And then we're going to label this axis Pokemon quantity. Now remember, this is just a mock dataset. You can fill it with any data that you want, or you can import a legitimate dataset. Okay, so this is the equation that we get from our trend line, and we're going to create it on our own and calculate the coefficients by hand. So this is the equation that we have. And that over there is the sum of y. You can find it over there. Then you have the sum of x squared, which is over here. And the sum of x over there, and the sum of x times y. And n is the number of items in our dataset. So first we calculate x times y. And we can take 59 times 81, and this is our answer. And then we can just spread it across. And then we got our product of x and y. We can create the sum of that, so then that will give us sum of x times y. And then we can do the same for x squared, where you take the square root of 43. We can do the same for the rest of the dataset, and the same we can do for y. So we take y times itself, get 6,561, and then we have the sum already. Now you can do the same for Pokemon, the sum of the Pokemon quantity, as well as the urban density. That will give us the sum of each of our features. So we need to calculate our coefficients. So we have A, B, and R squared. So we can say equals, put in our brackets, and the first one is the sum of y. And then you can enter the equation into the formula bar. I'm going to speed up this part of the video so it's not so monotonous. And then there you have it. We have 65, which is the same number that we get from our trend line. Now we can do the same for B. I've already done this before, so I'm just going to copy that and paste it there. You can do this by hand to get a feel for how to enter the equations. Let's see if you get the same thing. So it's quite simple. You just need to enter the equation as it is into Excel. And then you can do the same for R squared. As you can see, linear regression is very easy and simple. Okay, so in the next lecture, we're going to see how we can use this in Python using scikit-learn. See you in the next lecture. Please don't forget to like, subscribe, and share.
Okay, here we have like an experience using Excel, how to use linear regression. Then here, this is Andrew Ng, the most well-known machine learning professor at MIT. and also Stanford online. So we'll have like 8-minute explanation about another type of regression. We call it logistic regression as classification technique. So we'll start.
In this and the next few videos, I want to start to talk about classification problems where the variable y that you want to predict is discrete valued. We'll develop an algorithm called logistic regression, which is one of the most popular and most widely used learning algorithms today. Here are some examples of classification problems. Earlier, we talked about email spam classification as an example of a classification problem. Another example would be classifying online transactions. So if you have a website that sells stuff and if you want to know if a particular transaction is fraudulent or not, whether someone has, is using a stolen credit card or has stolen the user's password, that's another classification problem. And earlier we also talked about the example of classifying tumors as cancerous, malignant, or as benign tumors. In all of these problems, the variable that we're trying to predict is a variable y that we can think of as taking on two values, either 0 or 1, either spam or not spam, fraudulent or not fraudulent, malignant or benign. Another name for the class that we denote with 0 is the negative class, and another name for the class that we denote with 1 is the positive class. So 0 may denote the benign tumor, and 1 positive class may denote a malignant tumor. The assignment of the two classes, spam, not spam, and so on, the assignment of the two classes to positive and negative, to 0 and 1, is somewhat arbitrary, and it doesn't really matter. But often there is this intuition that the negative class is conveying the absence of something, like the absence of a malignant tumor, whereas 1, the positive class, is conveying the presence of something that we may be looking for. But the designation of which is negative and which is positive is somewhat arbitrary, and it doesn't matter that much. For now, we're going to start with classification problems with just two classes, 0 and 1. Later on, we'll talk about multi-class problems as well, where the variable y may take on, say, 4 values, 0, 1, 2, and 3. This is called a multi-class classification problem. But for the next few videos, let's start with the two-class or the binary classification problem, and we'll worry about the multi-class setting later. So how do we develop a classification algorithm? Here's an example of a training set for a classification task for classifying a tumor as malignant or benign. And notice that malignancy takes on only two values, 0 or no, 1 or yes. So one thing we could do, given this training set, is to apply the algorithm that we already know, linear regression, to this data set, and just try to fit a straight line to the data. So if you take this training set and fit a straight line to it, maybe you get a hypothesis that looks like that, right? So that's my hypothesis, h of x equals theta transpose x. If you want to make predictions, one thing you could try doing is then threshold the classifier output at 0.5, that is at the vertical axis value 0.5. And if the hypothesis outputs a value that's greater than or equal to 0.5, you predict y equals 1. If it's less than 0.5, you predict y equals 0. Let's see what happens when we do that. So let's take 0.5, and so, that's where the threshold is, and thus, using linear regression this way, everything to the right of this point, we would end up predicting as the positive class because the output values is greater than 0.5 on the vertical axis, and everything to the left of that point, we will end up predicting as a negative value. In this particular example, it looks like linear regression is actually doing something reasonable, even though this is a classification task we're interested in. But now let's try changing the problem a bit. Let me extend out the horizontal axis a little bit, and let's say we got one more training example way out there on the right. Notice that that additional training example, this one out here, it doesn't actually change anything, right? It's, looking at the training set, it's pretty clear what a good hypothesis is. It's that, well, everything to the right of somewhere around here, to the right of this, we should predict as positive, and everything to the left, we should probably predict as negative, because from this training set, it looks like all the tumors larger than, a certain value around here are malignant, and all the tumors smaller than that are not malignant, at least for this training set. But once we've added that extra example out here, if you now run linear regression, you will instead get a straight line fit to the data that might maybe look like this. And if you now threshold this hypothesis at 0.5, you end up with a threshold that's around here, so that everything to the right of this point you predict as positive, and everything to the left of that point you predict as negative. And this seems a pretty bad thing for linear regression to have done, right? Because, these are our positive examples, these are our negative examples. It's pretty clear we really should be separating the two classes somewhere around there. But somehow, by adding one example way out here to the right, this example really isn't giving us any new information. I mean, it should be no surprise to the learning algorithm that the example way out here turns out to be malignant. But somehow adding that example out there caused linear regression to change its straight line fit to the data from this magenta line out here to this blue line over here, and caused it to give us a worse hypothesis. So applying linear regression to a classification problem usually isn't, or often isn't, a great idea. In the first instance, in the first example, before I added this extra training example, previously, linear regression was just getting lucky, and it got us a hypothesis that, worked well for that particular example. But usually applying linear regression to a data set, you might get lucky, but often it isn't a good idea. So I wouldn't use linear regression for classification problems. Here's one other funny thing about what would happen if we were to use linear regression for a classification problem. For classification, we know that y is either 0 or 1, but if you are using linear regression, well, the hypothesis can output values that are much larger than 1 or less than 0, even if all of your training examples have labels y equals 0 or 1. And it seems kind of strange that even though we know that the labels should be 0 or 1, it seems kind of strange if the algorithm can output values much larger than 1 or much smaller than 0. So what we'll do in the next few videos is develop an algorithm called logistic regression, which has the property that the output, the predictions of logistic regression, are always between 0 and 1 and doesn't become bigger than 1 or become less than 0. And by the way, logistic regression is, and we will use it as a classification algorithm, is maybe sometimes confusing that the term regression appears in its name, even though logistic regression is actually a classification algorithm, but that's just the name it was given for historical reasons. So don't be confused by that. Logistic regression is actually a classification algorithm that we apply to settings where the label y is discrete value when it's either 0 or 1. So hopefully you now know why, if you have a classification problem, using linear regression isn't a good idea. In the next video, we'll start working out the details of the logistic regression algorithm. In this and the next few videos,
Okay, guys, I hope that you have a clear idea now that we have different types of regression, different type of classification. What do you mean by supervised learning? That could be consist of classification or regression. Regression has different type, and we deal with continuous target variable. With the classification, we are looking for a discrete value output. So these things, and what is the difference between linear regression and logistic regression? We'll come back to those next class using presentation with some real example, with some programming example. So all of those we will start on it, and with machine learning like SVM, with linear kernel, with the multilinear kernel, with the nonlinear kernels, with KNN, which use distance based algorithm or a tree, like decision tree, or like what else, like probability model, like naive Bayes. So I will start talking about machine learning algorithms in details, methodologies, as a classifier and as regression model. So we'll talk about all of those starting next week. So be ready. Questions still here? If you don't have a question, you are free to leave. If do you have like anything about the project, or you need the approval for your topic, you can wait if you pick. If not, you can contact me at any time via email in order to approve. And please always CC Afshan, the TA. So his input is very valuable to me. If you don't have any question, you are free to leave. If you have, you can wait. I'll stop recording here. So anything about the topic title will be not recorded. Thank you, and see you next week. Thank you. Thank you, Ryder. Thank you, Louis. Thank you, Roping. Thank you, Yigang, Shuming, Shulan, Hankum.